Hello everybody, and today we are going to identify lines of symmetry. Okay, so what does that mean, symmetry? A 2D shape is symmetrical if a line can be drawn through it so that either side of the line looks exactly the same as the other, and we call this a mirror image. So if we just have a little look at this shape right here, we can see that if I was to fold over one half on the other half, it would be exactly symmetrical. Okay? Okay. So shapes can have a vertical, horizontal, or diagonal lines of symmetry. Okay? Sometimes it can get confusing with vertical and horizontal. So if you think of the horizon, that's why I've put the picture of the horizon here, and horizontal. So horizontal, think of horizon across, horizontal, okay? And vertical is going to be down, and then of course diagonal at an angle. Could go this way, either diagonal. And just to remember that shapes can have more than one line of symmetry. So just let's remind ourselves of the names of some of these regular 2D shapes, and regular meaning that all of these sides are the same length. So we've looked at these earlier in the week. We have an equilateral triangle here. Each side is the same. A square, 4 equal sides. A regular pentagon has 5. A regular hexagon has 6. A heptagon has 7. A regular octagon has 8. A regular nonagon has 9. A regular decagon has 10, and a regular dodecagon has 12. A dodecagon, that is one for the Zoom quiz. I think you could throw in now at some point. And remember, like we said, regular meaning that the sides are the same length. And one thing to note with 2D shapes that are regular, they will have the same number of lines of symmetry as they have sides. For example, a square has 4 lines of symmetry. Okay, so 1, 2, this isn't very straight, 3, 4. Yeah, that's not straight, but it has the same number of lines of symmetry as it has sides. Just a little tip. Now, which of the following shapes have more than one line of symmetry? I'd like you to pause the video and take a look, remembering that your line of symmetry can be vertical, horizontal, or diagonal. Pause the video and take a look. Okie doke. So hopefully you've recognized that these shapes here, so the star and the rectangle and the triangle and the circle have more than one line of symmetry. And the star has, in fact, showing you down here, 5 lines of symmetry. This rectangle here has 2 lines of symmetry. This regular equilateral triangle has 3 lines of symmetry. It's very difficult to draw, but 1, 2, and 3. That brings us to the last one, the circle. How many lines of symmetry does a circle have? Well, actually, a circle has an infinite number, meaning there is no end to the number of lines of symmetry in a circle. Infinite. Okay. Which shape has the correct lines of symmetry marked? I want you to pause the video and take a look and see which one you think is correct. Remember, it means that if one side was folded over onto the other, they would match up absolutely exactly. Have a pause and just think about that. Well, I hope you have identified that in fact A is the shape, the quadrilateral, the irregular quadrilateral that has the line of symmetry correctly marked. This one is incorrect because if we were to fold this side on top of this, it would not match up. And likewise here, if we were to go from this corner to this corner, that would not work. And if we went across here, that would not work either. This line of symmetry down here, vertical line of symmetry, is the one that is marked and is correct. Okay. Match the halves which go together to make symmetrical shapes. So I want you to pause the video and see which halves you think match up. And I hope you've recognized that E and F would go together, B and D would go together, and also C and A would also match up together also. This would have to be rotated round, mind you. We'd have to rotate that round to match them up, but they would match perfectly together and be symmetrical. Okay. Pair the lines of symmetry with the shapes they match. So hopefully we talked about regular shapes and lines of symmetry at the very start. You should be able to figure this out. So pause the video and take a little look. So I've just put them over here. E and D go together. 3 lines of symmetry. 1, 2, 3, sorry, not exactly. F and C will go together because I have a square, it has 4 sides, and I can see I've got 1, 2, 3, 4 lines of symmetry. Remember, it's a regular shape, same number of lines of symmetry as it has sides, so 4. And here, of course, I have A and B. How many lines of symmetry? This isn't exactly on center here when I placed it over. It just wouldn't line up exactly. But let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, and it's an octagon, so it has 8 sides, so it has 8 lines of symmetry too. Okay, here's something to look at. Ustace has filled in the Venn diagram with shapes. So her Venn diagram, she has shapes with vertical lines of symmetry going down and horizontal lines of symmetry. And it says, find and explain his mistake. Can you spot anything that's incorrect on this Venn diagram? Take a look and see. Okay, so just looking at this irregular quadrilateral here, or a trapezium, this shape has a horizontal line of symmetry. Let's see if I can just use the blue line here. I've got this diamond or rhombus here in the middle that has both a vertical and a horizontal line of symmetry. And vertical, I do think this shape here, even though it's not, I don't think, perfectly straight, but I tried to make it as straight as possible. This was not an easy one. is a heptagon. It has 7 sides and that has a vertical line of symmetry. But just looking up here at this pentagon, 1, 2, 3, 4, 5, it's got 5 sides, and in its current orientation, or the way that it is sitting, it just does not have a vertical line of symmetry. It has a horizontal. So this shape here, our pentagon, does not belong there. This was a tricky one. It wasn't, and maybe on your sheets, so I thought it was a little bit strange how some of the shapes, so I've had to try and blow them up to show you. And anyway, so you could be forgiven because I think it was a little bit of a strange question, this one. Okie dokie. So here is an image made up of several shapes, which we can see here. How many lines of symmetry does the image have? Not the shapes, does the whole image have? You can pause the video and take a look. So remember, one side should be able to fold over exactly on the other and it will match perfectly. Hopefully you have identified that this shape just in fact has one line of symmetry, which is a vertical line of symmetry. If we were to go across here, okay, these shapes would not line up exactly on top of each other. Those parallelograms would not line up correctly on each other. Here are 3 attempts at drawing reflections. Find the reflections that are not symmetrical and explain why. Have a very, very close look. Again, you have to look incredibly carefully to spot this, but hopefully you will be able to. So pause the video and take a look. And hopefully you can spot that A and B are not symmetrical. For A, you can see here that this side is bigger than this side. Only fractionally, but still bigger nonetheless. On B, you can see here that this line here is slightly slanting up, so that would not be exactly symmetrical. And for C, yes, you can see that that reflection, that one side would absolutely fit and mirror the other if they were folded over. Okie doke. Well, I think that's it for today for symmetry. Good luck, and please let us know if you have any questions at all. Okay then.